Here we're going to talk a little bit more about inertial reference frames. Imagine a situation where you're riding in a car and the car stops suddenly and you feel thrown forward in the car. You do have a forward acceleration relative to the car, but there's no force that is pushing you forwards in that situation. When we talk about Newton's laws and the laws of physics in general, we define inertial reference frames as one in which Newton's laws are valid. The interior of this crashing car is not an inertial reference frame because you are feeling an acceleration towards the front of the car with no force, and so your force equals mass times acceleration is not valid in this situation. What's happening in real life is that you are the object in motion and you are tending to stay in motion. The car is either hitting an object or braking suddenly and has a force slowing the car down. You don't have the same force slowing you down, and so you continue forward as the car slows down. So what's happening, in fact, is that the car has a deceleration, a negative acceleration, relative to you. You, being an object in motion, tend to stay in motion and tend to keep going forward. So that's what's happening in real life, but from your perspective as an observer, you feel a forward acceleration relative to the car that isn't there in real life, and thus it cannot count as an inertial reference frame. Another example is being on an airplane that is cruising at a constant velocity. If you put a ball on the floor, it will remain at rest relative to the airplane. The airplane is going at a constant velocity, so there's no horizontal forces on the ball, so the ball is not accelerating, the ball is sitting still. The airplane is moving at a constant acceleration, so it has no acceleration either. So in this situation, Newton's first law is satisfied, and so the airplane counts as an inertial reference frame because of the constant acceleration. And in fact, if you've ridden a plane, you know that once you are at cruising altitude and once you are not accelerating in changing direction or changing speed, being on the plane feels normal. And if you're not looking out a window, you wouldn't necessarily know that you're riding a plane. And so any sort of experiment you do, from bouncing a ball and looking at how the ball moves as you drop it and then let it bounce up and catch it again or whatever, any sort of experiment like that would behave and would react exactly as it would if you're on the ground, because in this situation you're in an inertial reference frame. If we look at a similar situation, though, where our physics student and the ball are in an airplane during takeoff, so during the run up the runway where we're accelerating very quickly from rest up to several hundred miles per hour in order to fly, in that situation, there are no horizontal forces acting on the ball, but the ball would roll backwards in the airplane. In the same way, the physics student standing there would feel like they were being pushed towards the back of the plane. And what would be happening in that situation would be friction between their shoes and the ground is transferring that motion of the plane to accelerate the student and push them forward to keep them moving with the plane. But if the acceleration was too great, the student could fall backwards as well. And so, again, in this situation, because you feel like you're being pushed backwards inside the plane when there's no forces acting on you, this is not an inertial reference frame. And in fact, to speak more generally, accelerating reference frames are not inertial reference frames, because those accelerations make it seem like there are forces acting, and thus you have accelerations between the object in one frame versus the object in another frame. Those accelerations are taking place even though there are not necessarily any forces directly acting on that object. And if that's the case, the presumption that the laws of physics will work breaks down. The laws of physics are assumed to be constant, but only in inertial reference frames for this very reason.